All right, guys, this is Miss Katz again, and today we are going to talk about how we can solve for an unknown or a missing piece of a proportion, okay? We're going to use all that same knowledge that we used to determine if a proportion was truly a proportion to find the missing piece. So we're going to start by taking a look at this first example. This is on page 13B in your MSG. We know that the relationship that we've got here is 4 to 36. And this will equal some number. This u is a variable. It means it can change. It's something we don't know. It's representing a number that we don't know yet. We're going to find it. And that number over 9 needs to make a proportion. Now, we talked yesterday about the three methods. And again, they were substitution, ratio table, or butterfly method, right? All of these play some role in solving these equations. So here's the deal. I'm going to start by using the ratio table method. If I know this relationship, how would I get from 36 to 9? Henry. How, if I start, there you go. I'm going to divide by 4. And whatever I do to the bottom of a ratio set or a fraction set, I have to do to the top. So if I take 4, divide it by 4, what will you have to be to make this a proportion? 1. Now, can we prove that using the butterfly method? Let's take a look. If we take 4 over 36, and we take 1 over 9 now, because you guys just told me that u is the same as 1, and we do the butterfly method, what do you get when you multiply that side? 36. What do you get when you multiply here? So they are in proportion, which means we found the right number to make the proportion. Does that make sense? Okay. Look at example number 2. Okay, in this case, I've given you the 1/9, and I've given you the 36, and we have to get to this u. How can I get from 9 to 36? Now, Henry. There we go. Now we're multiplying by 4. Whatever I do on the bottom, again, I'm always going to do on the top. So when I multiply by 4 up here, what's u going to be? 4. And again, we could cross multiply to prove it, right? If u is 4, what's 4 times 9? 36. And 1 times 36 is? 36. We can prove that we got it right. Okay? Does that make sense to everybody? Let's take a look. I'm actually going to walk you through all 6 problems at the bottom here because we're going to do a lot of extra practice today. I just want to make sure we're really clear. Okay? So take a look at question number 1. Do I have a really good relationship here I can use ratio tables on? Not right now. Do I have a fraction I could simplify? Yeah. Who said yes? Caleb, which one can I simplify? 4 over 20. You got it. And what factor do 4 and 20 share, honey? 4. 4. So if I divide by 4 on top and bottom, what do I get? 1 over 5. So I'm going to rewrite this problem, and this is what it will look like now. Remember, these are equivalent. I just gave them new clothes. I made them look a little different. Now I could probably use that ratio table method, right? So let's take a look at that. How would I get from 5 to 15? Times 3. Times 3. Whatever I do on the bottom. Do to the top. So 1 times 3 is 3. Now I'm going to take this problem over here and I'm going to use the butterfly method to solve it as well because I want you guys to see that. So I'm going to rewrite, since we already simplified, I'm going to use the simplified version, okay? So I'm going to rewrite this over here. Now, we know if this is really a proportion, when I cross multiply, when I multiply this guy, it's got to equal this side, right? Mm-hmm. What is 15 times 1? 15. That needs to equal whatever 5 is times r, right? Whatever r is, times 5. Now, what times 5 will get me 15? 3. And if you didn't know that off the top of your head, if you take 15 and you divide it by 5, what number do you get? 3. So really, the algorithm for this particular model is the 2 numbers that you know, you multiply, and you always divide by the third. Okay? Next unit, we're going to talk about actually solving equations to get there. This unit, I just want you to remember, take the 2 numbers you know, multiply them, and then the extra one will be the number we divide by. And every time, that will get you your answer. Both ways, we got that r equals 3. Does anybody have a question on that? Sometimes the butterfly method is going to be the best method because we can't find a good relationship to use that ratio table. All right, so now here, for example, let's say we just looked at this exactly as it was given. Do I have a great relationship that I can use ratio tables for? The way it's written, I really don't. So we could right now go right to the butterfly method. I told you the two numbers you know you're going to multiply. What is 10 times 20? 200. Oh. And what's the extra number that we need to divide by? 8. That's the number we didn't use yet. So we would divide by 8. You guys all have the ability to do that on your paper. Make sure you check it for me. Go do it for me. Don't sit here and look at me. See, when you're paying attention, you're in good shape. Got it? Everybody in here knows that long division algorithm. We've used it a bunch. So what you should have on your paper should look something like this. 8 goes into 20 2 times. And 8 goes into 40 5 times. So what is the answer here? So y equals 25. I want you to notice that each of these problems, the variable changes. Doesn't matter. It's just representing some number we don't know. It could be any letter you want. It could be a smiley face. It could be Cece's face sitting in there, really cute, smiling at you. Doesn't matter. It just represents something I don't know. Okay? Let's take a look at question number 3. Here, again, do I have a clean and easy relationship I can use a ratio table on? Well, 3 and 30, if we were simplifying fractions by multiplication, they might be helpful. But for this one, remember, we're looking from bottom to bottom. How did I get from one to the next? So I don't really have a grid. I mean, there is a number that we can multiply times 4 that will get me 30, but I don't know it off the top of my head. It's not a whole number. So what method would be the best method to use for this problem? Nope. Butterfly, right? I don't have a good, easy relationship here that I can find, but I can use the butterfly method. What is 3 times 30? 90. And what number are we going to divide by? What? 4. Do that on your paper. 90 divided by 4. When you've got it, just stand up. That way you don't have to put your arm on. Just quietly stand up. Those of you who are standing, did you get something other than a whole number? Okay. Your answer should not be a whole number. Remember that if you get a remainder, we can keep going. We just have to drop a what? A 0, but before we drop the 0, we have to drop a what? Decimal. So remember, the nice thing about the way that math goes, right? We learned all about decimals and division and all of that. Now we're just applying those same skills over and over again. I'm just going to start the process. Kobe, 4 went into 9 how many times, honey? 2. When I subtracted, hopefully everybody is at this place right now. And then I bring down the 0. How many times is 4 going to 10, Ibrahim? 8. Nope. 4 goes into 10. How many times? 2. It makes an 8. Now, here's where the issue is, and I have a feeling you guys can all get to the 22. Mm-hmm. And that would be okay too, but it's not as easy to work with from there. You add a 0. Hold on. You can't just add a 0. First, I add a decimal. So I'm going to add a decimal back here because it's there. Remember, we're just not seeing it. We don't need it right now, so it wasn't visible. And whenever I add that decimal, I can add another 0, and we can keep dividing. How many times is 4 going to 20? 5. Don't forget that that decimal floats up also. So the answer here is going to be 22.5. Now, if you put 22.5, I would take that as well, because that is true. If you put 22 2/4, you didn't simplify. Okay? What I want you to understand is, now that we have decimals and fractions in our repertoire, Those are fair game, just like whole numbers are. So sometimes your answers will not be whole numbers, and that's okay. If you get one and it seems weird, you can always check things. All right, let's take a look at number 4. In my third period class, of course, that was the one that was most often asked for me to go over. Why? Because there's a what? Decimal. And for some reason, 6th graders are allergic to decimals. I don't understand. So here, again, do I have a clear relationship between the 4 and the 5 where I could use a ratio table? No. But I do have another method, which is the what? The what? Nope. Butterfly method, which is what we've been doing, right? We're going to make those wings. Raise your hand or when you can tell me what 2.5 or 2 5/10 is times 4. You got it, CJ? What is it? 10.0. And what's the number that we're going to divide by? 5. What is 10 divided by 5? 2. J just equals 2. And look, guys, 2/4 is equivalent to a half, right? And 2.5 happens to be half of 5. It's the same relationship.
So if you see the decimal, you will divide.
Whenever we're using the butterfly method, we always multiply the two numbers and divide by the third. Okay? Take a look at this problem. Now, I don't have a great relationship between 12 and 27, 12 and 21. But can I simplify that second fraction? Yeah, Ayana, what goes into both 21 and 7? Wait. No, you're going to get a 3, but what goes into them?
7.
Yeah. Divide by 7 on the top and on the bottom. So our new problem will actually look like this. What do we get on top? 3. And on the bottom?
7.
Which one is 1? There we go. Now, how did I get from 3 to 12?
4.
Times 4. Whatever I do on top.
Just the bottom. 4.
Okay. And so A equals 4. Any questions on that now? Are we getting the pattern here? Take a look at this last problem. Can we simplify? I would always recommend that first because it does make your life really easy. CJ, what'd you get? What number goes into both of these guys? Well, you're going to get a 3 at some point, but what 7. Divide by 7. So K over 3 stays. And this becomes what, guys? 2 over 3. Now, how did I get from 3 to 3?
Divided by 1.
Times 1 or divided by 1. Either one will work. And whatever I did in the bottom? Times 1. What do we get?
2.
Now, did I have to go through all that work? No. If the bottoms are 3 and we want them to be equal, the numerators also have to be equal. So if the numerator of one of them is 2, the other one's got to be 2. Okay? Uh-huh.
Can we do it in a different way?
Yeah.
Because I did 8 times 14, that was 20. It's 22.
Yep. Absolutely. If we use the butterfly method and you didn't simplify, 3 times 14 got you what? 42?
Yeah.
And then divided by 21 is still 2. Any of those will work. Okay? Anybody have a question on how to solve for one missing piece? All right. We're going to flip to page 14A. I want to show you how to do this when it's a word problem. It's not any more difficult. Okay, we're going to look at question number 1 about Matthew. Let me just get it all set up. Find my mouse.
Pay attention to this guy.
This really is easy. If you guys pay attention, you've got this. Okay? All right. The first thing you have to do when you are solving a word problem, ladies, gentlemen, you don't want me to call you out on the screen because your parents could watch. First thing we're going to do is identify the 2 things we're comparing. So in this problem, somebody tell me the 2 things we're comparing. Tiziana. You got it. Miles and hours. Make sure you guys underline them, circle them, something to help offset them. Now, the way that I do these problems is like this. I know I'm comparing miles and hours. This lets me know those are the 2 units I'm dealing with. Can you open the door, Tiziana, please? And we're going to use those relationships. The miles will always be on the top, and the hours will always be on the bottom. Now let's look at what they gave us. The relationship they gave us was how many miles? 10 miles in how many hours?
4 hours.
Okay, that's our first ratio. Our relationship that we know is they went 10 miles in 4 hours. What else did they give us? Caleb. So does the hours go in the top or the bottom? Bottom, right? Hours are on the bottom. So that 18 is going to go here. The thing we don't know is going to sit up in the miles. We have to figure out how many miles they went in that number of hours. Does that make sense? Now, this problem right here is just like the problems we just did. I would highly recommend you do what first? What's the magic S word? Simplify. So what do 10 and 4 share in common? 2. Let's divide by 2. Let's rewrite this problem. What does this fraction turn into? 5 over 2. Still equals some number we don't know over 18. How did I get from 2 to 18? Times 9. Whatever I do on the bottom.
45.
So there's 45. Now here's where it gets a little different. It's a word problem. What did that 45 represent? The miles or the hours?
The miles.
Yeah, we were looking for the number of miles. It even says, how far can he go? That's our miles. So make sure that your answer reflects that these are 45 miles, not just plain old 45. There's a reason. They serve a purpose.
Okay.
Make sense? So the only difference between this page and the page before is that we've got to figure out what the ratios are first, then we can solve them. We're going to do number 2 together.
The only difference is, I would suggest that we let them try to understand that should be the statement form, right? Because it's a word problem. So Matthew hiked 45 miles in 18 hours. All right?
Oops. Yeah, you can always finish it in 18 hours. That way you're connecting those two ideas. Okay, let's take a look at number 2. We're going to do one more practice problem, then I'm going to give you guys your homework. And those of you who still need help, you can pay attention to me. I'm going to start doing your homework with you. Those of you who are ready to go, you just keep working. Okay, that's how we're going to spend the rest of our day. So let's take a look at question number 2. Please raise your hand if you can tell me the 2 things we're comparing here. Who haven't I talked to yet today? Arthur. Cups to what? What are you making with those cups of sugar? Cookies. So I'm going to put a CU to represent cups, CO to represent cookies. You can use anything you want. You can make drawings. It doesn't matter. Just something to remind me that the cups are always here and the cookies are always here. Now, it doesn't matter which one's on top as long as you're consistent. If you wanted to put the cookies on top, that's okay as long as cookies are always on top. Does that make sense? In this case, they told us how many cups of sugar? How much? 2 and 5/10 or 2.5 or 2.5. And how many cookies did that amount of sugar make? 12. What was the other piece of information that they gave us?
36.
36 what?
Cookies.
So does that go on the top or the bottom? Bottom. These are where the cookies go. So we're looking for how many cups of sugar we needed to make those 36 cookies. How do I get from 12 to 36? Mackenzie. There we go. That's okay. And whatever we do on the bottom, we're going to do on the... So we're going to take that 2.5 or that 2.5 or that 2 and 5/10 and multiply it times 3. I'm going to do the math just so you guys watch it and you can see it. And how many places are after decimals here? 1. So it should be 7.5 what?
Cookies. Oh, yeah. Sugar.
What cups of sugar? And to write it in a sentence, so that's the answer we're looking for. That's the piece. And I want to make sure I separate that. Kids in my last class were giving me a ratio. Didn't ask for the ratio of it. I asked for how many cups of sugar would I need. Now, to write it as a sentence, okay, it says how much sugar is needed. 7.5 cups of what?
Sugar.
Is needed to make?
36 cookies.
There we go. That should be your final answer. That way it tells me you understand what we're looking for. Now, let me show you what your homework's going to look like. And then I'm going to sit here and do your homework. I'm going to do 3 on each side and then any more that I need to. If you're ready to go, you don't have to look at me at all. But you have to be quiet because there's going to be some of you who need some extra help, and we'll just keep plowing through until you feel like you got this, okay? I'm going to end the video here, and you guys can refer to this if you need to when you get home.